notation again today in a graph and also in an equation. So look at the warm-up. Can you identify the following? Independent variable, dependent variable, domain range, and is it a function or not? So this is average miles per gallon over time, and if in a graph, the independent variable is always on the bottom. So here's our time. It's the independent variable. And the dependent variable in a graph is always on the y-axis, and here it's average miles per gallon. So I'll put average miles per gallon of certain cars. Domain is all possible x values. So in our graph, our lowest value, it looks like it starts at 1949, it looks like. And this is x value. And the highest year I see here is 2001, 2, 3, 4, 5. So 2005. Oh, it says right here. So 2005. So again, domain is all possible x values that we see on the graph. Range is all possible y values. So let's look at the lowest y value here and the highest y value. So it looks like our graph goes from about, I would say, I don't know, 13.5 miles per gallon. And it goes up to about 23, I'm going to say, miles per gallon. And does this pass the vertical line test? Yes, it does. So yes, it's a function. Okay. It says in the world there are two common units of measurement for temperature, Fahrenheit and Celsius. There's a way to convert from one unit of measurement to the other. Would this represent a function? Why or why not? Well, let's graph it and see what this would look like. So if I open a graph page, we're going to type in this function. The 9/5 I'll put in parentheses. 9 divided by 5 is 9/5. So it's 9/5 c. When we graph it, our variable has to be x, so I'll change the c to an x, plus 32. And I have to change my my window because here my y-intercept is 6.67. It has to be 32 or above. So let's go to menu window. Let's change our window settings. Let's just go from -6 is fine. Let's go up to, how about like 50? See what that looks like. Okay, so we can see that this is linear, has a slope and a y-intercept. So yes, this is a function. Yes, it's linear. It would pass the vertical line test. This can be written, so if it's a function, it can be written in the form f of x equals 9/5, and we'll put x here, plus 32. We know this as function notation. So when I say f of 10, what does that mean? It means 10 is x, which is the Celsius here. It means when it's 10 degrees Celsius, what is degrees Fahrenheit? So let's plug in and find f of 10. So here's what it would look like if we plug in. F of 10 equals 9/5. We're going to plug in a 10 plus 32. And if we solve that, we have fractions here, so let's reduce. 5 goes into 10 twice, so this is times 2. So this is 18 plus 32. And 18 plus 32 is 50 degrees. So what it means is when it's 10 degrees Celsius, it's 50 degrees Fahrenheit. What does f of x equals 60 mean? Well, this is the answer. It means when it's 60 degrees Fahrenheit, what is the temperature in degrees Celsius? So let's solve that. Plug a 60 in for f of x. We'll subtract 32 from each side. 60 minus 32 is 28 equals 9/5 x. It's being multiplied. We can divide by 9/5, but use parentheses. So here's what it looks like in our calculator. 28 divided by 9/5, then parentheses. Okay, oh, I should have hit Control, Enter. So it's about 15.6 degrees Celsius. So when it's 60 degrees outside Fahrenheit, it's 15.6 degrees Celsius. Okay, review and a graph. When you have the input, how do you find the output? So here's our function, find h of 7. It means plug in a 7 for x, so we have 10 plus 3 times 7. So we say h of 7 equals 10 plus 21. So we say h of 7 equals 31. It means you plug in a 7, 31 is the answer, the y value. Let's find h of 0.5. We have 10 plus 3 times half. So h of 0.5 equals 10 plus half of 3 is 1.5. So we say h of 0.5 equals 11.5. So when you plug in a 0.5, your answer is 11.5. Now sometimes I'll give you the output, the answer. Here's our function g of x. Find x if g of x is 10. So here's the answer, 10 equals 0.5x minus 2. And now we have to use algebra to solve. So we're going to add 2 to each side. We have 12 equals 0.5x. Take half, or divide by half. If we divide 12 into halves, we get 24. So when g of x is 10, x is 24. So the answer is 10, the output's 10, the input's 24. Let's try the next one. I'm just going to clear this. Find x if g of x is 4. So put the 4 in for g of x of 4 equals 0.5x minus 2. We'll add 2 to each side. We get 6 equals half times x. Take half of 6, so divide 6 by half. When you divide 6 into halves, we get 12. So when the input's 12, the output is 4. Last thing, when you have a graph, how do you use function notation? The following graph shows the amount that Ryan has in his bank account over the last 11 months. Find f of 3. So f of 3, this is the x value right here. So find when x is 3, go up and over. He has $500 in his account. So it means after 3 months, Ryan has $500 in his bank account. Find f of 11. That means after 11 months, so here's 11 months, he has $800 in the account. So this is 800. Find x if f of x is 800. So this means at 800, we're going to go work backwards. And we can see that x is 11. And what does f of x equals 800 mean? It means when does he have $800 in his account? And we know it's at 11 months. Find x of f of x is 200. So this is saying when he has 200 in the account, how much did that take him? How much time did that take him to save up? So 200 is right here, and it was from 7 to 9 months. Okay, so when you're looking at a graph, if I give you x, start at the bottom, go up and over. If I give you the answer, go over and down.